So the second type of factoring that we need to look at is when there is a number other than 1 in front of the x squared term. And there's just a couple extra steps involved in this versus the previous examples where there was no number in front of the x squared term. So what you would think you would have to do is just start factoring the 12 because that's the last number. But first we have to multiply the 2 by the 12, which gives us 24. And the 24 is what we actually need to factor. So I'm going to start doing that. But again, our goal is to find factors that add to 10, the middle number. So we've got 1 and 24. We've got 2 and 12. 3 times 8. And 4 times 6. Okay. And the numbers that could add to give 10 would be 4 plus 6 gives us 10. And you might also have looked at this 2 and the 12 because if we had a negative 2 and a positive 12, then that could give us positive 10. But we have to have them multiply together to give positive 24. So negative 2 times positive 12 is negative 24, so that one doesn't work. So it has to be the positive 4 and the positive 6. And in this one, we have to do an extra step here, which is rewrite the equation. And notice instead of writing 10x, I substituted it with 4x plus 6x, which of course is just another way of saying 10x. So I haven't changed the formula at all yet. And now I need to look at the first two terms and the last two terms separately. So I'm going to look at these first two terms, 2x squared plus 4x, and determine the largest factor that is common between them. And so, let's see. Well, in both I can divide out a 2x. 2x squared divided by 2x is just x remaining. And 4x divided by 2x is 2. Okay, now I look at my last two digits here. I've got 6x plus 12. The greatest common factor between those is going to be 6. 6x divided by 6, I'm left with an x. 12 divided by x, I'm left with a positive 2. Okay, notice that we have the exact same thing in both brackets. That is good. Otherwise, something would have went wrong. So if you get to a point where you have different numbers in the brackets, then go back and check your work because somewhere something went wrong. Because to proceed, they have to be the same. So now, this part should start looking familiar. We do our two sets of brackets. In the first set of brackets, write what the commonality was in those two brackets above. And so that's x plus 2 is the same. And now we take the leftovers, which is the 2x plus the 6. Okay, and now we can set each equal to 0 and solve for x. So we're going to need to subtract 2 from each side, so x equals negative 2. And let's subtract 6 from each side. That's going to be 2x equals negative 6. And divide by 2. So that gives us x equals negative 3. So our answer is x equals negative 2, negative 3. And again, we can check our answer by expanding x plus 2 times 2x plus 6. And so that is going to be, let's see, x times 2x is 2x squared. X times 6 is plus 6x. 2 times 2x is positive 4x. And 2 times 6 is positive 12. Okay, and now I'm going to simplify that. Plus 10x. And that is what I started with. Okay, next example. Okay, so again, we have to take this first number and the last number, multiply them together. And now we can factor the 30. So factors are 1 and 30. 2 and 15. 3 times 10 is 30. 5 times 6 is 30. Okay. And we need to find the pair that adds or subtracts to negative 13. Oh, but of course we can also have negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, because two negatives multiply to give a positive. Okay, that add to equal negative 13. Let's see. Well, this one's close, but it's positive 13. This one right here. That's it. Okay, so now we know what we have to rewrite the equation with. 3x squared minus 3x. And it doesn't matter if I wrote minus 3x minus 10x or minus 10x minus 3x. You end up with exactly the same answer in the end. So don't worry there. Order does not matter. So now I need to look at the first two and the last two. Okay, the commonality here is the 3. With. So negative of x. Positive 10 divided by negative 10 is a negative 1. Okay, good. I have the same thing in the brackets. So I can set up my two sets of brackets here. Put what I found to be common among the brackets in the first set and the leftovers in the second set. Okay, so now I set each bracket equal to 0 and to solve for x. So in the first one I have x equals 1, and in here I'll have 3x equals 10 divided by 3, x equals 10 over 3. And you can leave that as a fraction because it does not simplify down at all.